So in this problem, we're going to take a look at how to go from one unit of concentration to another. So essentially what's given to us is 10.5% by mass solution of glucose, and they're asking for the molarity. So we're going to say, so this is given, and that's what we're supposed to find out. So what you want to do is you want to first take a look at the 10.5%, and let's write that out as, if it's a percentage, that means, let's say the total is 100 grams. So we can say that 10.5 grams is the solute in 100 grams of solution, because it's a percentage. So 10.5% of 100 grams is 10.5 grams. All right. Okay. So now the next thing we need to do is we need to convert the grams of solute, which is the glucose, into moles. Because why are we converting into moles? Because you're trying to find the molarity. And molarity is defined as the number of moles over liters of solution. All right, so let's find the molarity. So to find the molarity, we need the molar mass of glucose. Okay, so the molar mass of glucose, if you calculate it, it comes out to be 180.16 grams per mole. So a quick way to convert grams of anything to moles is to take the grams and divide it by the molar mass. So that's what we're going to do. We're going to take 10.5 grams and we're going to divide it by 180.16 grams per mole. And that gives us 0.05828, and it repeats and it goes on, moles. All right, so now we know the moles of solute, which is the glucose, and so we're done with that part. So let's put a little red check out there. So we figured that one out. Now we got to figure out, the next step is to figure out the liters of solution. Okay, so to find the liters of solution, the strategy out here is going to take the mass of the solution and use the density, which is given to us, to convert to the volume. So the way we would do this is, so if I write density is equal to mass over volume, m over v, and if we're solving for the volume, then all I need to do is let's put the density over 1. I need to flip this entire thing on its head. So then I get 1 over d is equal to v over m. And now if I multiply both sides with m, the mass, let's go ahead and erase the little flip, make that a little smaller. So now if I go put m out there, then those m's cancel out. So therefore volume is going to be mass over the density. So the mass we know is 100 grams. So we're going to calculate the volume as 100 grams over density is 1.03 grams per ml, which is what is given to us in the problem. All right, so this simplifies to 0. Sorry, not 0. This simplifies to 97.087 ml. We're not going to write all the digits out because we're just going to write enough digits so that we can, later on we'll kind of round because of significant figures. So we know that we have more than enough digits out here right now. Okay, so we know the volume in ml. The next step is we want to convert that milliliters to liters, because liters is what we need to convert to molarity. So to convert milliliters to liters, we'll use the formula. First of all, we need to know the conversion factor. So basically 10 raised to the power 3 milliliters is equal to 1 liter. And so the conversion factor is going to be 1 liter over 10 to the power 3 milliliters. So all we have to do is multiply this with 1 liter over 10 to the power 3 milliliters, and that gives us 0.097087 liters. So that is my volume in liters. So now the last step is, we know moles, we know liters of solution. We're just going to divide the two. So if we divide the two, so we're going to do molarity is equal to moles. That's what we calculated out here. Sorry, that's what we calculated out here. That's going to be 0.05828 moles over the liters, which is 0.097087 liters. And if we solve that, we will get 0.600 molar. And there will be some more digits out here, but we have to drop those because of significant figures, because the answer needs to be expressed with 1, 2, 3 significant figures because of 3 significant figures being given in the problem. I hope that made sense. Thank you for watching.